is decreasing, right? The entropy of the environment is blank. We know that entropy of the universe is always increasing according to the second law of thermodynamics, right?
Why? It has to stay the same though.
No, they were out otherwise. They can't use E for energy. So, let's think about it. If the environment, which is everything around the system, right? Okay? So environment and system are essentially going to make up the universe. Okay? That's what we're going to think of. Obviously, we don't have that much of an effect, realistically, on a different galaxy. Okay? But that's what we're talking about here. Is the system and the environment equal to the universe? So this is always increasing. This cannot be decreasing. These two together, both the entropies decrease. That means that everything's becoming more ordered. Everything's becoming essentially a single file, or in a perfectly order if you think about it in parts. Okay? Or it's H2, 3, 4, 5, 6. Everything's becoming ordered. The second law of thermodynamics says that that's impossible. Everything's going to disorderedness. Everything's getting more chaotic. Okay? That's what the second law of thermodynamics says. So the environment must therefore be increasing, getting more chaotic. Okay? More entropy. Okay? So a few people got that one right, but that's the way to think about it. Let's look at number 5. Use the passage for 5.3. The system consists of steam within the confines of a steam engine, whose cylinder and piston are shown in the figures below. Which of the figures describes a situation in which delta U, what is delta U? Internal energy is less than 0. Q is less than 0. What does that mean about Q, which is the heat? Is it absorbed or being released? Okay. So you look at your cheat sheet, Q is less than 0, so energy is released. Okay? And W is 0. So there's no work being done. So there's realistically only heat being released to the environment. So you're saying C? Yes. Right here you have the heat going out. Okay? It says it right there, steam condenses to hot water and is removed from the cylinder. Delta U is greater than 0, so your internal energy is greater than 0. That's not really going to help you guys too much. So the Q and the W is what's going to help you. Q is 0, so no heat leaving the system, and you know that work is less than 0. Work less than 0 means work is done on the system, or compression of gas. So let's see what it is. You said D. Piston moves forward, compressing that gas. It looks correct. Okay? Number 7, delta U is less than 0, Q equals 0. So there's no heat leaving the system or going in the system, and W is greater than 0. That means expansion of a gas. Excuse me. So that would be B. The last one, before you see the problem, is what? A. Yes. So that one, yeah. You have Q greater than 0, W equals 0, so Q is greater than 0. You have that energy going into the system. Do we have time for number 9? Yeah, we have about a minute and a half. Oh, it's an actual problem. We don't have time for that one. Are there any non-problems? Alright, an air conditioner is left running on a table in the middle of the room. So none of the air that passes through the air conditioner is transferred to the outside the room. Does passing air through the air conditioner affect the temperature of the room? Ignore the thermal effect of the motor running the compressor. What do you think? So you have an air conditioner in the middle of the room. Okay? We're going to say nothing is leaving the room. Is it affecting the temperature of the room? Ignoring the work law.
Yes.
Yes, very slowly. Where else can that energy go?
The exterior.
It can't go to the exterior unless the only way that this can leave is possibly through the walls or anything like that. Okay? Unless we assume it is an adiabatic process. So that would be the only place that could ever go. So no, because the air here moves from the cool air is returned to the room. Okay? We're assuming it's not leaving the walls. That's really the only place where it goes. You guys have a great day. I will see you guys.
You may suffer from exhaustion, but that energy is